Congrats for completing the OOPS and C# questions because was the most important section of .NET interviews. Now we have a fresh new topic here, .NET Framework. And first, as always, we will start with the basics in .NET Framework, and here is the list of 7 basic questions. For example, questions on components of .NET Framework, GAC, reflection, serialization, deserialization, globalization, and localization. Most questions are theoretical here, but they are important to know because while coding, we should know what is happening in the background, right? So the approximate duration of all these questions is just around 15 minutes. What are the important components of .NET Framework? Here is the diagram which shows the main components of the .NET Framework. Now, while coding for any application, we need not to bother about these components because these are automatically managed by the .NET Framework. But as a theory, we should have some basic idea what are these components and what they do. Let's see what they do. First, the most important one is CLR. It stands for Common Language Runtime. First point about CLR is CLR manages the execution of programs, for example, operations like memory management, security checks, etc., etc. Second point is CLR provides execution of managed code only. What is managed code? Code written in any .NET supported language such as C#, VB.NET or F# is called managed code. Then what is the unmanaged code then? For example, Java language is not supported by .NET Framework, and that is unmanaged code. If you try to copy paste some Java code in Visual Studio, then it will not compile it because it is not supported by the CLR. I know you will never do it, but this is just for information, okay? Next important component of .NET Framework is CTS. CTS stands for Common Type System. CTS basically is a set of rules that defines how types are defined, used and managed in the .NET Framework. Types like integer, string, double managed by CTS only, okay? Next important component is CLS. CLS stands for Common Language Specification. CLS is a subset of CTS. It defines a set of rules that every language must follow which runs under .NET Framework. The benefits of the CTS and CLS both is if you create same program logic in different .NET languages, okay, then the compiler will generate the same DLL for them, okay. Other example is suppose you created two projects, one is in VB.NET and another in C#. Now you want to use one project as a reference in another. Then it will work seamlessly because both languages are .NET Framework supported. And CLS CTS job is to make sure that the two languages projects can interact with each other. Got it? Now the next important component of .NET Framework is FCL. FCL stands for Framework Class Libraries. FCL is the collection of classes, namespaces, interfaces, and value types that are used for .NET applications. For example, you create your application and there we use some common classes like string, array list classes, right? These are common classes we used in our project. These are nothing but the framework class libraries. We also call them sometimes base class libraries. But there is a small difference between FCL and BCL. BCL is actually a subset of FCL. Therefore, some classes which are in FCL are not the part of the BCL. But all the classes of BCL are the part of FCL. So FCL is at high level, okay? Now in the diagram, you can also see the types of project we can create in .NET Framework here, like ADO.NET, ASP.NET, Windows Form, etc., etc. Okay, these are the types of project we can create in .NET Framework. And at the top of the diagram, you can see the types of languages supported by the .NET Framework: VB.NET, C#, J#, and many more. In 80% of the project, we use C# only. But yes, there are other languages also there. Alright, so that is the brief idea about all the components of the .NET Framework. What is an assembly? What are the different types of assembly in .NET? Let's see the definition first. Assembly is unit of deployment like exe or a DLL. What does it mean? When you create your code and you build the solution, like your project, you build it, then the .NET framework convert your code into intermediate language, and that intermediate language is placed inside the assembly, and you can also say DLL also, which you can find inside the bin folder of your project. That is assembly. Okay, now there are three types of assembly. First one is private assembly. A private assembly can be used by a single application only. Okay, it is not accessible outside. So all the projects you create will by default create private assembly for you. For example, you created two projects inside one solution, and then you want to add assembly 1 project to assembly 2 project. Then it is possible because these all are private assembly and inside the same solution. Now the second type of the assembly is public or shared assembly. They are same things. Okay, shared assemblies are usually libraries of code which multiple applications can use. It is registered in the global assembly cache. For example, you created one class library, okay, which is like a reusable component for not just yours but for other outside projects also. Okay, then you will register your assembly class library in global assembly cache, and then it will be converted to public or shared assembly. Then there is a process to register the assembly which I will discuss in later questions. Okay, so now the next assembly is satellite assembly. A satellite assembly is defined as an assembly with resources only, no executable code. Okay, if you ever worked on an application which supports multiple languages, then you might be aware about this .resx files. Okay, this is one example of satellite assembly. These files are not executable codes, remember, these are just resources only, and they are called satellite assemblies. So this is all about the basics of assemblies and the types of assemblies. What is GAC? If you know about public or shared assembly, then you must be have heard about GAC also. Here are 3 points which we should know about GAC. GAC stands for Global Assembly Cache. Second point, GAC is the place where public assemblies are stored. Okay. Then third point, private assembly can be converted into public assembly by adding them in the GAC using GAC util tool. So this is the tool with the help of which you can add one assembly as a public assembly. Okay, I think this is enough information about GAC. What is reflection? Let's see the definition first. Reflection is the ability of a code to access the metadata of the assembly during runtime. Now, what is metadata? Metadata is information about data. For example, if book is a data, okay, all the content inside the book is a data, then title, author name, these are metadata because this is the information about the book. Okay, so now the question is, when there is a requirement to write the code using reflection, okay, when we have to write the code. So one example is, suppose you have to check the version of your application assembly at runtime. Then you can write the reflection code like this. Here you can see we are using the assembly class of the system.reflection namespace. Okay, this assembly class belongs to system.reflection namespace. Here first we are getting the assembly details by calling the get executing assembly method, and then from this assembly object we will get the name of the assembly, and then from the assembly name object we will finally get the version of this assembly, current assembly. So the reflection concept is used to extract the information about the assembly at the runtime. Okay, this is what you will run the application, and then this assembly information you are getting. Now the other popular class of the system.reflection namespace is type class. This type class is used to get the information about the methods we have used in our application, or you can say assembly. So if you will pass a method as the parameter as a string format, then we can get all the details of that method, basically the type we can get. Okay, so this is the answer of this question. What are serialization and deserialization? What are the types of serialization? Very important question, okay? Let's see the definition of the serialization first. Serialization is the process of converting an object into a format that can be stored, transmitted, or reconstructed later. For example, you create objects of the classes, right? Now you want to pass the object to other applications outside your project. So how can you do that? You can pass in your project, but outside in other application, how can you pass the object? Now you cannot pass it directly. For that, you will use serialization to first convert the object into bytes and then save it in database memory or file storage like this. Or you can also like directly transfer the bytes to the other application, okay? Now we have mostly three types of serialization: binary serialization, XML serialization, and JSON serialization. Binary means like convert object to bytes. XML serialization means converting object to XML. And nowadays the most used is JSON serialization, which means like this application 1 converting object to JSON format with the help of serialization first, and then send this JSON to some other application 2 through the network. And in that application 2, with the help of the deserialization, convert the JSON back into the object format, and then that object you can use in application 2, right? So deserialization is the process of converting serialized data such as binary, XML, JSON data back into the object. Now the thing is when to use serialization. So as I said, it is mostly used in web APIs to convert class objects into JSON string, and like deserialization used back to convert JSON into object format. Like this, you can see we are creating one object of employee class, setting the properties, and then with the help of this JSON convert class, we are and serialize object method, we are converting the object back into the JSON format. So we are converting the object to JSON format, which then we printed, and then we are getting this as the output. Now sending this the object in network is difficult, but this JSON string you can easily transferable in any network, okay? So this is the whole idea about the serialization. What is meant by globalization and localization? These two are very related terms and there is some confusion sometimes about them. So let's clear that confusion today. So let's see the globalization first. Globalization is the process of designing and developing a software product that can support different cultures and regions of the world. In short, you can say like multiple language support, okay? For example, you just started developing an application. Now, this application you want to support multiple languages in the world. Then you will do globalization, okay? Now, what is localization then? So localization is the process of adapting a globalized application to a particular culture local. Okay, so let me explain. For example, after you have created one application that follow globalization because that is supporting multiple languages. Like this, you can see here one application is supporting 6 languages. All right, that is globalization. Now 1 year later, your manager asks you to add one more language like Japanese in this list. So then what you will do? Then you will do localization of this globalized application for a particular language. So this is the localization. So globalization is like creating application for supporting multiple languages, and localization is like then allow it to support one more language. So related terms but slightly different meanings they have. What are Windows services? Let's see the definition first. Windows service is a computer program that runs in the background to execute some tasks. For example, in your Windows machine you can run this command services.msc and you can see the Windows services like this. These are the Windows services only which are created by Microsoft to support the Windows operating system. Like, okay, your operating systems are supported by these Windows services. Now you can also create a Windows services for your application, for your project, and then you can add here. So for example, you want to set one reminder service which will send automated emails to your customers in every 1 hour. For that, you will create one Windows service from your like Visual Studio. That is, you have to select Windows Service project and add the logic and add the business logic, like whatever email or whatever you want to do in that service, and then you will add that service here. Okay, then that service will be visible here. Mostly servers are used for that purpose, not these local computers are not the best things for them. Now few more things about Windows services are like Windows services can be started automatically or manually. Automatically means you can set the timings. Okay, so within 3 hours the service will run and the service will send the emails. Okay, or you can also manually pause, stop and restart these Windows services. So great, that is the brief idea about the Windows services you have now. Great. After completing questions on .NET Framework Basics, we will cover questions around garbage collection in .NET. This will not take much time as we have only 5 questions here. We do not have to code anything for garbage collection, okay? But knowing what is happening in the background is really important from interview point of view. The approximate duration of all these questions is just around 9 minutes. What is garbage collection? This is a very important question like abstract class and interface differences. So let's see the definition first. The garbage collector manages the allocation and release of memory in .NET Framework. If you remember CLR, then you remember it manages the execution of program, right? Operations like memory management, right? So garbage collection is one of the responsibilities of CLR, which is the part of the .NET Framework work only. For example, suppose you create one project and write this code. When application will run, this employee object will be created and then it is used to call getSalary method. But after that, what will happen to this employee project? This object is still there in the memory with no use, right? Now this is the responsibility of the garbage collector to dispose or release this employee object. So garbage collector will dispose this employee object automatically when it is no longer needed. Similarly, you can have many objects in your application like this. See how there are so many objects present in the memory and so less free memory space is there before garbage collector run, right? And after garbage collector will run, many unused objects or resources are released or disposed. And then the free memory level has also increased, which is really good, right? So that is the job of the garbage collector and that is what is garbage collection. What are generations in garbage collection? Now we already know garbage collection is to release the objects which are no longer needed, right? So .NET Framework has a mechanism to decide which objects are no longer needed, and that mechanism we call generations. Generation is a mechanism to collect the short-lived objects more frequently than longer-lived objects. Let me explain this, okay? Now, there are 3 types of generations, generation 0, 1 and 2. When garbage collector will run first time, it will put the newly created objects in generation 0, okay? Garbage collector will also check here that if there is any object which is already present in this generation 0, then if the object is still in use inside the application, if the answer is yes, then garbage collector will move that object to generation 1. But if this object is no longer in use, then this garbage collector will dispose the no longer used object and claim its memory, okay? The same way, sometime garbage collector will visit generation 1 and will check whether the object present there are currently in use or not. If object is in use, then garbage collector will put them in generation 2, and if it is no longer used, then again it will dispose them. Now the point is, garbage collector will more frequently visit generation 0 and only sometimes it will visit generation 1 and will very rarely will visit generation 2. That means The objects in generation 1 and 2 are lived more than generation 0 objects, because garbage collector do not visit generation 1 and 2 generation frequently, right? The conclusion is the objects which are used more and needed more will be first be promoted to generation 1 and then generation 2. And if there are more and more required, then garbage collector will never release them, okay, will never dispose them. So that way garbage collector with the help of generations dispose the short-lived objects more frequently than the longer-lived objects. That is what was the definition was, right? I hope now you have some understanding of generations in garbage collection. This is again a very important question here. What is the difference between dispose and finalize? First, let's see what is the similarity between them, okay? Both dispose and finalize method are used to release the unmanaged object which are no longer required. This is the similarity. Now the difference is finalize method is called automatically by the garbage collector, but the dispose method is called explicitly by the code to release any unmanaged object. Meaning you have to do nothing to call the finalize method, it will automatically call by the garbage collector. But yes, for dispose method you have to write the code. Now if you know using statement, then you know internally this using will call the dispose method of SQL connection class, right? Because SQL connection class of .NET framework has already this dispose method. But suppose you have some class like this employee class and you want to implement dispose method for employee class. So you have to write some code, something like this here. Now this implementation whole is not important to remember, but you should be aware about this, that this is the thing. First implement like employee from iDisposable interface you have to implement. Then this dispose method you have to implement here. Inside the dispose method you can call one dispose method. Remember this dispose is different from the above one, okay? You can name something else to do it also, okay? So that is the here down you can see the dispose method body, and here you can release the unmanaged or managed objects as per the requirement. And after that, like this SQL connection class you can use using statement with employee class also. I'm not getting into the details of the implementation of dispose method here, because our actual question was what is the difference between dispose and finalize method. And as I already said it, finalize method is called automatically by the garbage collector, but the dispose method is called explicitly by the code to release any unmanaged object. That you have to remember. What is the difference between finalize and finally methods? There is no relation between these except their names are somewhat similar. Finalize method is used for garbage collection. So before destroying any object, this method is called as part of the cleanup activity by garbage collector. On the other hand, if you see this code, then you will know finally block is used in exception handling. So the definition is finally block is used in exception handling for executing the code irrespective of the exception occurred or not. Another difference is garbage collector will call finalize method automatically in the background. So you do not have to write any code for it, okay? But here is the code where you have to write the code for finally block here, okay, right? The code inside this block will definitely execute irrespective of this exception. So basically you have to write the code for finally block, okay? So that's it, that's are the differences. Here is one tricky question. Can we force garbage collector to run? We all know garbage collector to run automatically by the .NET framework, right? But can we somehow force it to run? The answer is yes. By calling gc.collect method, we can force garbage collector to run in our application. But this is not recommended. Instead, better to use dispose method. This is the sample code here where we are first creating two objects obj1 and obj2. Then we are setting them to null, which will indicate they are no longer required. and therefore eligible for the garbage collection. And finally, we will trigger this method gc.collect method, which is the part of the system namespace. So the memory used by these obj1 and obj2 object will now be released. This is the way, but it is not recommended. The reason is gc.collect will call garbage collector, which will start checking all the other objects also, right? Which is then very costly performance will be there. Rather use dispose method, because that will only release the objects which you want to release. That will not check all other objects, and that is the answer. Great. Now we will cover one advanced concept in .NET, and that is threading. Nowadays, asynchronous programming is very popular, and every .NET developer should know it. If you see these 5 questions, then we will cover questions on process, threads, multi-threading, synchronous, asynchronous programming, task, async, and await. All these terms are related to threading only. Therefore, I put them together in a sequential manner, okay, so that you can understand and learn step by step and can answer them in the interviews. The approximate duration of all these questions is just around 16 minutes. What is the difference between process and thread? Let's see one diagram first, okay. Here is a very high level diagram of the operating system. Inside that, suppose we have 3 processes. So these 3 processes are independent and occupying separate memory for them, alright. Whereas if you see closely, we have multiple threads inside each process, and these threads share the resources like memory and other resources of this process only. And threads run concurrently inside the process. They can be interconnected also like this, okay. So now the definition is, a process is an instance of a program with its own memory space and system resources, whereas a thread is the smallest unit of process that shares memory and resources with other threads also within the same process, okay. So one process can have multiple threads, and now you got the high level understanding and the differences between the process and the threads. Explain multi-threading. Let's try to understand with the help of diagram. Here we have 2 processes. One is single process P with single thread inside it, okay. And another is single process with 3 threads. Second is the multi-threading case because we have more than one thread. So the definition is, multi-threading refers to the ability to execute multiple threads of code concurrently within a single process, okay. The benefit of multi-threading is, multi-threading allows you to perform multiple tasks simultaneously, such as you can download data while displaying a progress bar in your application. That is all together, right? Now to implement multi-threading, the basic requirement is, to create multi-threaded applications in C#, we need to use system.threading namespace. Alright, these are like the basics of multi-threading which you should know. What is the difference between synchronous and asynchronous programming? Now let's try to understand synchronous programming first. It's very simple. See here we have 3 methods, method 1, 2 and 3, and they are returning 10, 20 and 30. This method 1 has this sleep 500, which will make this method very slow to execute, right? Because it will take some time, right? In real applications also, there are big methods which take time to execute, right? Now from inside the main method, we will call these methods one by one like this. And then just printing the result, so the output will be like 10, 20 and 30. Now this is synchronous programming. One by one methods will execute, right? Methods are called. So in synchronous programming, code is executed in a sequential manner. The problem with this is, as this first method is executed slowly, so the other methods which are not even related to it, they still have to wait for the first method to finish, which is like not a performance friendly thing, right? It will take time, right? So in synchronous programming, only single thread is available and it will execute step by step, which is therefore slow in execution. To resolve this, we will use asynchronous programming with the help of the task now. For that, we will use these same methods for asynchronous call also. Now see the code of asynchronous programming by using task. The difference is here we are using this task.run method of task class by calling all the methods, first the method 1, then method 2 and then 3. So what will happen now? First, when the execution will come here, your debugger will come here, it will see the task and then immediately it will create one more thread for thread here, okay, and then thread 1 will remain here, and then the next thread 2 will be moved to the next point, while the previous thread 1 is still working with this method 1. Again thread 2 will see task and create one more thread like thread 3, and that will move to the next line. So this means now all the 3 threads working parallelly, simultaneously and doing their jobs, right? Do not bother about this lambda operator if you don't know this. Just understand this is used to call this method, okay? You can do it by other way also, but I used it to just keep the code as shorter as possible, okay? The main point is working of task and multi-threading should be clear to you, right? As a result, if you will see the final output, we will get 20, 30 and then 10. The result is different this time. Why? Because this 10 is at last. Why? Because here in method 1 has took more time to execute and returning this 10. Whereas other threads gave their normal outputs like 20, 30, they took the same time. So this is the benefit of the synchronous programming with the help of task. They will take less time and they are more performance friendly. So the definition of the asynchronous programming is, in asynchronous programming, tasks can be executed independently of each other, right? Now you got the idea of both synchronous and asynchronous programming now. What is the difference between threads and tasks? And what are the advantages of tasks over threads? First, the common thing between thread and task is, in .NET, thread and task are two different ways for doing multi-threading only, okay? The purpose is only one, and that is doing multi-threading. Now then, what is the difference? Thread is a general programming concept, okay? On the other hand, Microsoft created task in .NET to simplify the use of threads, okay? Getting it? In other words, you can also say that tasks are like a wrapper over threads, and task internally uses threads only, because threads are the actual things. Tasks are just like a wrapper. In other words also, like, threads are the actual and original programming concept which is used by all the programming languages like Java, C#, etc, etc. Whereas task is created by Microsoft to help developers to make it easier to work with threadings, okay? So if you are coding threadings, that is slightly difficult, but if you are coding task, that is slightly easy. Now you can also say that if a thread is like a cycle, then task is like a motorcycle, okay? So for example, see the example of thread implementation here. All right, creating the object, then calling the method long time running thread, then starting the thread with thread.start method. But if you see the task code, see, simpler code doing the same thing and do not even need this .start method like threads. This is one advantage of tasks over threads. Now let's see all the advantages of task over threads, okay? First advantage is simplified code, which I already explained. Second is exception handling is easy in task as comparison to threads. The next advantage is task can return a result, but there is no proper way to return a result from thread. The next advantage is we can apply chaining and parent-child relationship on multiple tasks, but it can be very difficult in threads. So if you have multiple tasks, so you can relate them, you can chain them, like one by one they will execute, and that is very easy to do with tasks, but it is very difficult to do with the threads. In short, We have to code a lot to handle errors, avoid memory leaks, optimize performance in case of threads. But in case of tasks, most of these things are taken care by the task class of the .NET framework only, and we have to write less numbers of codes to do the same thing. So now you know the differences and the advantages of tasks, right? Great job. What is the use of async and await keyword in C#? This is a very important question and asked in many interviews. Now we already know these facts in previous questions. In synchronous programming, task is executed in a sequential manner, right? In asynchronous programming, tasks can be executed independently of each other. Now the definition of async and await is: async and await are keywords which are used to enable asynchronous programming only. And if we remember, in previous question we have 3 methods. Then this is the synchronous way to call these methods. Then next is the asynchronous way to call this method using task class, right? The point is now, why we need async and await? Task class is enough for running the method simultaneously, right? See, tasks are great, but the problem is they are capable to run independent methods. But in real world applications, in real projects, mostly one method is dependent on other method. For example, suppose here this method 1 will return 10, right? And then the 10 will be passed as the input I of method 2 method as the parameter. So in short, method 2 input is dependent on method 1 output, which means we cannot execute method 2 until we get output from the method 1, right? So how to achieve this? Because tasks are good for independent methods, but these are slightly dependent methods. For that, we have to use async and await to do asynchronous programming. Now let me show you the code. First, here is the main method. Okay, here since method 1 and 2 are dependent on each other, we put them inside the single method 1_2 method like this. Okay, but method 3 is still independent, so we called it separately. It's like the same earlier like. Now here method 1 and _2 method, we will first mark this as async. That means this will be now an asynchronous method. Asynchronous method means the first thread of the program will go inside this method and then it will print this test. Okay, now remember that when it will see the await keyword here, until watching this await keyword, the first thread was working synchronously. Okay, it is here synchronously and it will print a test. Now listen very carefully. But when thread 1 will see the await keyword here, immediately it will create the new second thread, which is you can call T2. Okay, so this second thread T2 will go back to the calling method. What is the calling method here? This main method. And T2 will start executing the next line of the code's calling method 3. Now how many threads we have in total? We have 2 threads. One is T2 thread 2, here inside the main method it is working, and another is thread T1, which is still here at the await point. Now that is why async await always work together, because if you will not put any await keyword inside the async method, then whole execution will be the synchronous only, right? And then what is the point of making the method asynchronous by putting this async keyword? So there is no point. Therefore, .NET compiler also will not allow async without await, because they work together. Okay. Now here the thread T1, if you remember, will wait for the await operation to be completed. Okay, it will not move forward until this method 1 operation is complete. It will get the result I from the method 1 and then only it will jump to the next line here. So it will something be like sequential. Okay, after watching this await keyword. So finally, let's discuss the output here. Okay, so first print is test, because until here everything is synchronous. Second output is 30. which is the output of method 3, because that is executed parallelly by this second thread T2. If you remember that T2 was working there, and it is fast because it do not have any sleep condition inside the method 3, right? The third output is 10, which is the value of the variable I, which first thread T1 got from method 1, right? See the method 1, it is returning 10 from here, okay? And the last output is 200. So which is basically when variable I, which is 10, is passed as the parameter in method 2, then inside the method body, if you look at the method 2 body, the parameter 10 will be multiplied with the 20, and then it will result as 200, right? From the method 2. And finally that 200 will be printed here. Got it, I think so. Finally, the definition of the async and await keywords. If you will see, the async keyword is used to mark as the method as an asynchronous method, okay? And the await keyword is used to pause the execution. Remember, it paused the execution of an asynchronous method until the specified operation complete. So once again, if I will try to conclude the whole thing, so first we will mark the method as async. Now the first, it will the things will be happen in synchronous way, and when it will see the await keyword, the new thread, the second thread will be created, and then your method will be like asynchronous, like because two threads are working. Now remember, it's in synchronous case, one thread is always there. So see, we have that is not multi-threading, because one process will have one thread, and that is sequential, that is synchronous. But if more than one threads are there, that is asynchronous, that is multi-threading, right? Great. All right, now I think it's clear to you what is asynchronous programming, what is async and await, what is multi-threading, what is task, what are so if possible, you can try to code the same, and then you will know the differences in a much better way. This is the mock interview number 4. In this mock interview, we will cover topic .NET Framework, and we will see questions from .NET Framework, components, garbage collection and threading. So let's see all the questions. Here is the list of the questions. Before pausing the video, I want to give you some motivation. Giving interviews is a difficult task, but success doesn't come by doing easy things. You got the booster now. Now you can pause the video and think about the answers of all these questions. If you are done with the questions, then until now you have a good sense about the interviews. If you are consistently able to answer more than 50% of the questions, then you are ready for any interview. Let's move ahead.